Click the bell icon to get latest videos from Ekeeda.
Hello friends, today we are going to discuss problem number 11. It's based on optimization of a transportation problem. Let's read the problem first. Here's our problem. Ekeeda Outsourcing Company Limited has production centers at Mumbai, Chennai and Kolkata. So we have got three production centers, Mumbai, Chennai and Kolkata. So they are the place of origin from where we are supplying the goods. The company has its distribution centers at Ahmedabad, Bhopal, Bangalore and Goa. And we have four different distribution centers. These are the centers from where we are going to consume this quantity manufactured by the three centers Mumbai, Chennai and Kolkata. The production costs are equal and fixed at all the three centers. However, the variable costs are only the transportation cost. So the cost of production and all the other costs are same at all the three centers, but the cost of transportation varies. It changes according to location. The monthly production at Mumbai, Chennai and Kolkata are 10, 12 and 15 respectively. So this comes to 10 plus 12 plus 5, which is 27,000 units is my total. It's my total supply. The monthly demand at company's four centers, Ahmedabad, Bhopal, Bangalore and Goa are 12, 8, 4 and 30,000, which comes to 12, 20, 24 plus 30, 54,000 units respectively. So we have got a problem where we have three centers and we have four distribution centers and three production centers. The transportation cost per unit from different centers to different distribution centers are given in the following table. So here we have the second page of the problem where they have specified what is the cost of transportation from each production center to each distribution center. Obtain a optimum transportation schedule so as to minimize the transportation cost. So our first and foremost objective is to optimize the solution. So this problem involves three centers and these three centers have a production of 10, 12 and 5, that is 27,000 units, whereas the total demand at the four different centers is 12 plus 8 plus 4 plus 30, 54,000 units respectively. So this is clearly a unbalanced problem. So we need to balance this problem. Let's see how to balance this problem now. We are doing the first part of the problem, that is we are obtaining the optimum transportation schedule to minimize the transportation cost. Then we will focus on the next question, B part. Right now we are just focusing on the A part. Let's draw the diagram of the table first. Transportation table. So here is my table. So here we have, friends, the centers Ahmedabad, Bhopal, Bangalore and Goa, and here we have Mumbai, we have Chennai and we have Kolkata. We already saw, we already discussed that this is an unbalanced problem. My supply is less than my demand. My demand is 54,000. So I need to put a dummy row in order to balance the supply. Let's see what is my supply and what is my demand. So here is my problem, page number 1. The monthly productions at Mumbai, Chennai and Kolkata are 10, 12 and 5,000. So here comes my Mumbai 10, Chennai 12 and Kolkata 5,000. This can be called as the supply, and we have monthly demand at the 4 centers Ahmedabad, Bhopal, Bangalore and Goa as 12, 8, 4 and 30, which I will note down here. My monthly demand or monthly requirement 12,000, 8,000, 4,000 and 30,000. So friends, we can see that my total demand comes to about 54,000, whereas my total supply comes to only 27,000. So we need to add a dummy of 27,000. This is my dummy row I have introduced just to balance the problem. Next thing we have in the problem is the transportation cost. Here is our transportation cost: 6, 14 and 4, 6, 14 and 4, 4, 10 and 10, 4, 10 and 10. And at Bangalore we have 14, 4 and 8, 14, 4 and 8. At Goa we have 12, 6 and 10, 12, 6 and 10. And then we have this dummy. As we know, dummy is introduced just to sort out or just to solve the problem. Therefore, there is no cost involved in case of a dummy. So let us introduce a cost of 0 for the dummy rows. Now my problem is completely balanced. Now the next question that comes in the mind of a student is, by which method I should solve this problem. We already have 3 different methods or 4 different methods, the 3 different methods to get the initial feasible solution: northwest corner rule, least cost method and VAM method. And then we have the Modi method to optimize the solution. Now since the problem is very clear in terms of the sentence, obtain the optimum transportation schedule. So we want a transportation schedule or a transportation cost which is optimized. Whenever a problem specifies that your cost should be optimized or your transportation schedule should be optimized, that means it is a minimization problem. And whenever nothing is specified in the problem and they want an optimum solution, we have only 2 steps. The first step is to get the answer by VAM method, and the second step will be to improve the solution and check the optimality by Modi method. Let's try to solve this problem by VAM method. So we are trying to find out the initial feasible solution by VAM method. So let us note down here IFS by VAM method. How to solve? We'll go row wise first. In the first row, my lowest cost in the first row is 4 and the next lowest cost is 6. The difference between 4 and 6 is 2. In the second row, my lowest cost is 4 and the next lowest is 6. Again the difference comes to. In the third row, the lowest cost is 4 and the next lowest cost is 8. The difference is. And in the last row, lowest cost is 0 and next lowest cost is 0. So the cost will be or the penalty will be 0. These are my row penalties. This will be called as the column penalties. In case of columns, in the first column I have the lowest number as 0, next lowest is 4. So 0 and 4, difference is 4. Second row, lowest cost is 0 and the next lowest is 4. Again the difference is 4. Third column, lowest cost is 0, next lowest is 4. Again the difference is 4. Fourth column, lowest cost is 0, next lowest is 6. So difference comes to. So friends, we have got the column penalties and the row penalties, and out of this, which is the highest penalty? The highest penalty from the rows and the columns is 6. So in this particular column, which is my lowest cost? 0. How much is my supply? 27,000. We have the highest penalty at 6. The lowest cost is 0. At this particular cell, my supply is 27,000 and my demand is 30,000. So 27 or 30, whichever is less, it comes to 27,000. So 27 minus 27, 0. 30 minus 27, 3,000. Since I got a 0 here, I will cancel this particular row. Since I cancel the row, my row penalties shall remain same. Now we'll recalculate the column penalties again. Here is my first column, lowest cost is 4, next lowest is 6, difference of 2. Second column, lowest cost is 4, next lowest is 10, difference of 6. Third column, lowest cost is 4, next lowest cost is 8, a difference of 4. And last column, lowest cost is 6, next lowest is 10, difference of 4. So if you can see in the second stage, I have got a penalty of 2, 2, 4, 4, 4, 6 and 2. Out of which the highest penalty is 6. So at 6, my lowest cost cell is 4, where I have a supply of 10,000 and I have a demand of 8,000. So 10 or 8, whichever is lower, it shall become 8,000. 8 minus 8, it will become a 0. 10 minus 8, it will become 2,000. Since I got a 0, in this particular column, this second column shall be cancelled. Now since we cancel the column, my column penalties shall remain same. My column penalties shall remain same. And I need to recalculate my row penalties. My first row, lowest cost is 6, next lowest cost is 12, the difference is 6. In my second row, my lowest cost is 4, next lowest cost is 6, difference is. In the third row, I have the lowest cost of 4, next lowest cost is 8, the difference is. So we can see the highest penalty we have at this stage is 6, and in this particular row the lowest cost is 6, where we have a supply of 2,000 and a demand of 12,000. So 2 or 12, whichever is less, it will be 2,000, and 2,000 minus 2,000, it shall be 0. 12 minus 2,000, it shall be 10,000. So we got a 0 in this particular first row. I'll just cancel the first row because we have got a 0 here. Since I cancelled a row, my row penalties shall remain same. And I need to recalculate my column penalties. In the first column, I have 14 and 4. The difference is 10. In the third column, I have 4 and 8. Difference is 4. In the third column, I have 6 and 10. The difference is again a 4. So we can see the highest penalty I have at this stage is 10. At 10, my lowest cost is 4, where I have a supply of 5,000 and the demand of 10,000. So 5 or 10, whichever is less. It will be 5,000, and 5 minus 5 it shall be 0. 10 minus 5 it shall be 5,000. Since I got a 0 here, my column will be cancelled. Now after the cancellation of this column, I am remaining with only one column, that the second, I am remaining with only one particular row, that is the second row, and therefore there will be no further calculation of penalties. I will directly allocate the 5,000 demand in the first column to Chennai, where we have a supply of 12,000. So 12 or 5, whichever is less, मैं यहाँ पे 5,000 लिया. 12 minus 5 it will be 7,000. 5 minus 5 it shall be a 0. Since we got a 0 in the first column, my first column shall be cancelled. Now I am remaining with only second row and only two columns. So I have a demand of 4,000 in the third column, and I have a supply of 7,000. So 7 or 4, whichever is less, it will be 4,000. 4 minus 4 it shall be 0. 7 minus 4 it shall be 3,000. Since I got a 0 here, this particular column shall be cancelled. Now I am remaining with only the first column. So here I have a supply of 3,000 and a demand of 3,000. I will simply allocate this 3,000 here. I will get a 0 here and a 0 here. With this, my column as well as my row is fully cancelled and my allocation is complete. So we have done this, we have obtained the initial feasible solution by WAM method. Now my second step will be to check the optimality of this solution, whether this solution I have got is optimal or not. That we need to find out. So let's proceed to the next step, that is checking the optimality of the solution by Modi method. Now we are going to simply copy this solution on a new page. So let's draw the lines first. So here I have Ahmedabad, Bhopal, Bangalore and Goa. And here is my supply, and we have Mumbai, Chennai, Kolkata and a dummy row. Then we have a demand here. So what are the numbers? Let's copy the numbers from the original table. This is my initial feasible solution obtained by the WAM method. Here are my numbers: 6, 4, 14 and 12. 6, 4, 14 and 12. 14, 10, 4 and 6. 14, 10, 4 and 6. 14, 10, 4 and 6. 4, 10, 8, 10. 4, 10, 8, 10. And the last, we have dummy row, we have a 0 here. And then we have the supply of 10, 12, 5 and a dummy of 27,000. 10, 12 and 5 and the dummy of 27,000. And we have a demand of 12, 8, 4 and 30. 12, 8, 4 and 30, which comes to 54,000. We have the initial solution. Let's see what was the solution. As per the initial solution, I was supposed to supply from Mumbai to Ahmedabad 2000 units. Mumbai to Ahmedabad 2000. Mumbai to Bhopal 8000. Then we have Chennai to Ahmedabad 5000. Chennai to Ahmedabad. Then we have Chennai to Goa 3000. We have Chennai to Bangalore 4 is the cost 4000. Then we have Kolkata to Ahmedabad 5000. Last we have dummy to Goa 27,000. Let's calculate U and V. We are trying to solve this problem to get the optimal solution. So we have the Modi method here. How to calculate U and V? As we have done it earlier, we are going to use only the occupied cells. So I'll introduce a 0 first in the first row against U. In the first row there are two occupied cells 6 and 4. So cost minus U will give me V. 6 minus 0, it will be 6. 4 minus 0, it shall be 4. So by using this 0, I calculated V values against two occupied cells. Now in the first column against 6, we have two more occupied cells. So now I will do cost minus V. I will get the corresponding U. So 14 minus 6, it will be 8. And 4 minus 6, again it is occupied cell. 4 minus 6 minus 2. So we had a 0 here. Then we had two occupied cells. 6 minus 0 is 6. 4 minus 0 is 4. There is no other occupied cell in the second column, so we skipped it. There were two more occupied cells in the first column, so we did 14 minus 6, 8. 4 minus 6 minus 2. Now I have got two more occupied cells against 8. One is 4 and one is 6. So 4 minus 8 minus 4, and 6 minus 8 minus 2. Then we have again in this particular column we have one more occupied cell with cost 0. Here 0 minus minus 2 will be plus 2. So we have obtained, friends, the U and the V values for all the occupied by using all the occupied cells. Now what we are supposed to do? Now we are supposed to test whether this solution is optimum or not. U and V are only the parameters that were used. Now we are going to calculate the delta value for all the unoccupied cells. So here is my new table or my new working. Delta values for unoccupied cells. So what shall be my delta values for unoccupied cells? This is my original table. We obtain the U and V values in the Modi method. We need to calculate the delta values for each unoccupied cell. Here is my space to write the delta values of unoccupied cell. My first unoccupied cell is Mumbai, Bangalore, where the cost is 14. So we are going to use the formula cost minus U plus V. So in my first case it will be cost 14 minus 0 plus minus 4. So Mumbai, Bangalore Our formula is cost minus U plus V. So in the first case it will be 14 minus 0 plus minus 4. For Mumbai Goa it will be 12 minus 0 plus minus 2. For Mumbai Goa it will be 12 minus 0 plus minus 2. For Chennai Bhopal it will be 10 minus 8 plus 4. For Chennai Bhopal it will be 10 minus 8 plus 4. For Chennai Goa already occupied, this is already occupied, then we have this unoccupied cell. Kolkata Bhopal 10 minus minus 2 plus 4. For Kolkata Bhopal this 10 minus minus 2 plus 4. Then we have Kolkata Goa, we skipped one. Kolkata Bangalore we have 8 minus minus 2 plus minus 4. So Kolkata Bangalore we have 8 minus minus 2 plus minus 4. 8 minus minus 2 plus minus 4. Next we have Kolkata Goa 10 minus minus 2 plus minus 2. We have Kolkata Goa 10 minus minus 2 plus minus 2. Then we have dummies. We have 3 dummies. Dummy Ahmedabad, dummy Bhopal and dummy Bangalore. So we have dummy Ahmedabad, dummy Bhopal and dummy Bangalore. At dummy Ahmedabad it will be 0 minus 2 plus 6. 0 minus 2 plus 6. At dummy Bhopal it will be 0 minus 2 plus 4. 0 minus 2 plus 4. At dummy Bangalore it will be 0 minus 2 plus minus 4. 0 minus 2 plus minus 4. Now for all these unoccupied cells we have 14 minus minus 4 which will become 14 plus 4 18. We have 12 minus minus 2 which is 12 plus 2 14. We have 10 minus 12 minus 2. We have 10 minus minus 2 plus 4 is 2. 10 minus 2 is 8. We have 8 minus minus 2 minus 4 will be minus 6. 8 minus minus 6 will be 8 plus 6, that is 14. We have 10 minus minus 2 minus 2 is minus 4. 10 minus minus 4 is 10 plus 4. 14. We have 0 minus 8. We have 0 minus 6. And we have 0 minus 2 plus minus 4, which comes to 2. So we got all the delta values for unoccupied cells. Let's copy these delta values in our table of Modi method. So we have 18, 14 and minus 2. So 18, 14 and minus 2. Then we have 8, 14 and 14. Then we have 8, 14 and 14. Then we have minus 8, minus 6 and 2. Minus 8, minus 6 and 2. So these are my values. Now since one of the delta value is negative, we have 2 or 3 negative values in the table. So we have minus 2, we have minus 8 and we have minus 6. Ignoring the signs, the highest number among this 2, 8 and 6 is 8. So we will take 8 as the base to make a loop to improve the solution. In the table, if you observe, we have got minus 8 in the dummy. So using this minus 8, I am going to draw a loop where I will come back to the same point and I will change the directions only at occupied cells. So I'll start from here. I'll go at 27,000. Then I'll go to 3,000. I'll go to 5,000. And I'll lead back to the same point from where I started. So loop is complete. I started from here, so I will give a positive sign here. I went to this, then I will give a negative sign here. Then I went to 3,000, again a positive sign. And again from plus, I will go to a. So we have drawn a loop here, friends. Now, how to optimize the solution? If you look at the table, we have two positive signs and two negative signs in the loop. In the negative signs, now look at the allocations, not at the cost. We have an allocation of 5,000 in the negative sign and 27,000. Out of this, the lowest is 5,000. So we'll subtract 5,000 from here, we'll subtract 5,000 from here. So this will become 0 and it will become unoccupied cell. This 27,000 will become now 22,000. And whatever we subtracted from these two particular cells will be added at this positive sign cells. Here it will become 3 plus 5, 8,000. And here it was earlier unoccupied. Now this shall become 5,000. So we simply subtracted 5 from here. We added the 5 here. We subtracted the 5 here. And we again added the 5 here. This way your problem remains balanced. Or else, if I subtract 5,000 from here, then it will become, instead of 12,000, it will become only 7,000, which will make the problem unbalanced. So to balance the problem, we have to always add whatever we have subtracted. So we have subtracted 5 and 5, 10,000 from here, and we added the same 5,000 to this corresponding two corners of the two positive cells. That way we balance the problem. Now what we have done is we have modified the solution by using the modified distribution method. However, we still need to check whether this is the optimal solution or not. For that, we'll draw a new table. We'll again apply the Modi method. Again, new values of u and v shall be calculated, and again new delta values shall be calculated. Let's jump to the next table now. So here I am drawing the table again. So here is our original table. I'll just copy the whole table again without the values of u and v in the new table. Second step in the Modi method. Here I am having Ahmedabad, Bhopal, Bangalore and Goa. Here we have Mumbai, Chennai, Kolkata and a dummy. We have the demand here, we have the supply here. So let's copy the whole table. 6, 4, 14 and 12. 6, 4, 14 and 12. 14, 10, 4 and 6. 14, 10, 4 and 6. 4, 10, 8 and 10. 4, 10, 8 and 10. 4, 8, 10 and 10. 4, 10, 8 and 10. 4, 10, 8 and 10. Just be careful with the numbers. And then we had a dummy where we had 0, 0, 0, 0. So 0, 0, 0, 0. And here was my supply 10, 12, 5 and 27,000. 10, 12, 5 and 27,000. And here we had 12, 8, 4 and 30. So 12, 8, 4 and 30, which comes to 54,000. We had our allocations. There were minor changes. 2,000 and 8,000 will remain same. So here it is 2,000 and here it is 8,000. Next we had Chennai, Ahmedabad now is unoccupied. We had 8,000 here and 4,000 here. So 4,000 at 4 and 8,000 at 6. Then we had Kolkata, Ahmedabad 5,000 and at dummy we had 5 and 22,000. Kolkata, Ahmedabad we had 5,000 and at dummy we had a 5,000 and then we had 22,000. Now we are just going to check the U and the V values again. Here is my U, here is my V. Before proceeding further, let's check the number of occupied cells. We have 1, 2, 3, 4, 5, 6, 7. So my number of occupied cells is 7. Number of rows plus number of columns minus 1 is 1, 2, 3, 4. 4 columns, 1, 2, 3 and dummy is the 4 and 4 rows, include the dummy also, minus 1 comes to 7. Since we are getting the 7 in both the in both the ways, I will say the solution is not degenerate. Now what we are supposed to do, we are supposed to calculate the U and the V values to test the optimality of the solution. So let's try to calculate the U and the V values. Now we'll introduce a 0 at the initial stage. Here is my 0 at against the first row. In the first row we have got 2 occupied cells. So 6 minus 0 will be 6 and 4 minus 0 will be 4. And from this 0 I got these 2 occupied cells. There is no other occupied column. In the second column we have 2 occupied cells in the second column. In the first column there are 2 occupied cells, 4 and 0. At this Kolkata, Ahmedabad we have cost 4. Cost minus V will give me U. 4 minus 6 is minus 2. 0 minus 6 is minus 6. So by using this 0 we calculated 6 and 4. By using the 6 I calculate this 2. Now in this particular row we have a dummy column with allocation of 22,000 and cost 0. So 0 minus minus 6 will be plus 6. And then we have one more occupied cell in this particular row or a column where the cost is 6 minus 6 is 0. So you are done with all the calculations. Now our next step will be calculation of the delta values for unoccupied cells. What shall be my delta values of unoccupied cells? Let's try to find out. I'll write in short now. Mumbai, Bangalore, cost is 14. 14 minus 0 plus, we haven't calculated this one V value. So it will be 4 minus 0, 4. So in the first column I have Mumbai, Bangalore, cost is 14. 14 minus 0 plus 4. So Mumbai, Bangalore, 14 minus 0 plus 4. Then we have Mumbai, Goa. Mumbai, Goa, cost is 12. 12 minus 0 plus 6. 12 minus 0 plus 6. Then we have Chennai, Ahmedabad, Chennai, Bhopal. For Chennai, Ahmedabad, we have cost 14 minus 0 plus 6. For Chennai, Ahmedabad, we have 14 minus 0 plus 6. And for Chennai, Bhopal, we have 10 minus 0 plus 4. Chennai, Bhopal, my cost is 10 minus corresponding U is 0 and corresponding V is 4. So 10 minus 0 plus 4. So Chennai, Bhopal, 10 minus 0 plus 4. Next is my Kolkata, Bhopal, 10 minus 2 plus 4. So Kolkata, Bhopal, 10 minus 2 plus 4. Next is my Kolkata, Bangalore, 8 minus 2 plus 4. So for Kolkata, Bangalore, 8 minus 2 plus 4. Next is Kolkata, Goa, 10 minus 2 plus 6. For Kolkata, Goa, 10 minus 2 plus 6. For dummies, we have dummy Bhopal, 0 minus 6 plus 4. For dummy Bhopal, 0 minus 6 plus 4. For dummy Bangalore, I have 0 minus 6 plus 2. For dummy Bangalore, I have 0 minus 6 plus 2. So with this I got 1, 2, 3, 4, 5, 6, 7, 8, 9 unoccupied cells. We have 1, 2, 3, 4, 5, 6, 7, 8, 9 unoccupied cells. Let's calculate the values. We have 14 minus 4, 10. We have 12 minus 6, 6. We have 14 minus 6, 8. 10 minus 4, 6. 10 minus 2, 8. 8 minus 2, 6. 10 minus 4, 6. 0 minus 6 plus 4 will be plus 2. And 0 minus 6 plus 2 will be 4. So I got the values 10, 6 and 8. 10, 6 and 8. Then we have got the values 6, 8 and 6. 6, 8 and 6. And then we have got the values 6, 2 and 4. 6, 2 and 4. So finally we have got a table here. This is my second table by Modi method, and in this table we observe that all the delta values of unoccupied cells are not negative, so they are either 0 or they are positive, and hence I can say that this table is the optimal table, or it will give me the optimal solution. So I'll just note down, since delta values are not negative, solution is optimal. Now how to get the solution? Let's continue on the next page. So my optimal solution, my total transportation cost shall be equal to 2000 into 6 plus 8000 into 4 plus 4000 into 4 8000 into 6 plus 5000 into 4 and then we have 5000 into 0 and for 22,000 into 0 which is the dummy. So we'll not note down the dummy in the final solution. So we have got 1 2 3 4 and 5 occupied cells in the final answer. Dummy we will not note down in the final answer. So here I have got 12,000 plus 32,000 plus 16,000 plus 48,000 plus 20,000, which comes to 12 and 32 is 40, 44, 44 is 50, 60, 1 lakh 8 and 20, 1 lakh 28,000 rupees. So friends, we have obtained the final solution by the Modi method. We modified or we used the Modi method twice to optimize the solution, and only after getting all the delta values of unoccupied cells as non-negative, that is they were either positive or 0, we have got the final solution. Thanks for watching this video. Do subscribe to our channel Ekeeda.